Okay, so good afternoon to one and all. In the previous lecture, we have discussed regarding parallel operation of transformer. So while operating the two or more than two transformer in parallel, there are some of the condition. I have already told the condition. So first one condition is that the polarity of both the transformer remains same. Okay, so before discussing about the condition, can anyone tell me what is mean by parallel operation? Parallel operation म्हणजे काय? What is mean by parallel operation? When we can call it as a two transformer are connected in parallel. कधी म्हणू शकतो आपण? When we can call it as a two transformer are connected in parallel. दोन ट्रान्सफॉर्मर पॅरलल मध्ये कनेक्टेड आहेत असं आपण कधी म्हणू शकतो? See, these are the two transformer are in parallel. When we can call it as this transformer A and transformer B are in parallel. कधी parallel मध्ये आहेत असं म्हणू शकतो आपण? Or what is the definition of parallel operation? Anyone? All of you present, no? Yes, give me reply. Hello. Give me reply. All of you present, no?
Yes, sir.
Okay. So two transformer are connected in parallel. That means the primary of both the transformer or primary of multiple number of transformer जेवढे आपण parallel मध्ये connect केले त्याची primary. So primary winding of both the transformer are connected to common supply, and the secondary of these two or more than two transformer are connected to common load. Then we can call it as these two or more than two transformer are connected parallel. त्यावेळेस आपण म्हणू शकतो दोन किंवा दोन पेक्षा अधिक ट्रान्सफॉर्मर हे पॅरलल मध्ये काय आहेत? कनेक्टेड आहेत. देन वी कॅन कॉल इट एज अ टू और मोर दॅन टू ट्रान्सफॉर्मर आर कनेक्टेड इन पॅरलल. ओके, गेटिंग? लक्षात आलं का?
Yes, sir.
ओके, प्रायमरी ऑफ बोथ ट्रान्सफॉर्मर जर दोन असतील or more than two असतील, primary of all the transformer which are connected to a common supply, and the secondary of these all transformer, that means two or more than two transformer are connected to common load. ज्यावेळेस ती common load ला काय केले? कनेक्ट केले. Okay, so then we can call it as these two transformer, that is transformer A and transformer B are operating in parallel. ते parallel मध्ये काय होत आहेत? ऑपरेट होत आहे. Okay, now when these transformer are operating in parallel, while putting this transformer in parallel, आपल्याला ट्रान्सफॉर्मर पॅरलल करण्याच्या अगोदर there are some of the necessary and sufficient condition is there. That means there are some of the necessary condition while putting two or more than two transformer in parallel. So in that first one necessary condition is that the polarities of both the transformer or the polarity of two or more than two transformer are equal. पोलॅरिटी काय पाहिजे? दोन्ही ट्रान्सफॉर्मरच्या किंवा दोन पेक्षा अधिक जे ट्रान्सफॉर्मर आहेत त्याची सेम पाहिजे. आफ्टर दॅट द टर्न्स रेशो, इट इज नॉट नेसेसरी बट दिस इज द कंडिशन, टर्न्स रेशो सेम. इफ नॉट सेम then also we are able to put the transformer in parallel. Again, necessary condition is that the percentage impedance and the percentage reactance of both the transformer remains same. दोन्ही ट्रान्सफॉर्मरचा पर्सेंटेज इम्पिडन्स काय पाहिजे? सेम पाहिजे. and it is having an same phase sequence and the voltage ratio. So these are the condition we have already discussed, and then only we are able to put two transformer in parallel. त्यावेळेस आपण दोन ट्रान्सफॉर्मर पॅरल मध्ये पुट करू शकतो. Okay, so these are the parallel operation of the transformer, and while operating two transformer in parallel, at that situation it will share load. या लोडचा पार्ट ते काय करतील, शेअर करतील अकॉर्डिंग टू देअर रेटिंग. And if the equal kVA rating transformer is there, equal kVA rating transformer असतील, we have derived the equation for that also. त्याच्यासाठीच आपण एक इक्वेशन डिराइव केलं होतं. So in that equation, see, for equal kVA rating or the equal voltage ratio, the equation becomes IA is equals to load current IL into opposite transformer impedance divided by sum of both the transformer impedance. दोन्ही ट्रान्सफॉर्मर ची impedance. Similarly, current share by transformer B न share केलेला current, it is equals to load current IL into opposite transformer impedance divided by sum of impedance of both the transformer. दोन्ही ट्रान्सफॉर्मर च्या impedance ची sum. Okay, so these are the load shared by each and every transformer. Now equating this to equation 7 and 9, we will get this equation. We have already calculated this equation. IA divided by IB is equals to ZB divided by ZA. Okay, so from above equation 9, it is clear that the transformer current are inversely proportional to the transformer impedance. ट्रान्सफॉर्मरचा जो काही करंट आहे, म्हणजे IA जर असेल तर IA हा त्याच्या इम्पिडन्सला इनवर्स प्रपोर्शन मध्ये. सो सी, हा IA इट इज इनवर्सली प्रोपोर्शनल टू ZA. IA it is inversely proportional to ZA, and IB it is inversely proportional to ZB. That means IA is inversely proportional to ZA. Current share by each transformer, it is proportional, that is inversely proportional to their respective impedance. त्याच्या respective impedance ला काय आहे, inverse proportional. Thus, for the efficient parallel operation of the two single phase transformer, the potential difference at full load across the transformer internal impedance should be equal. See, so if we want to efficient parallel operation, ज्यावेळेस आपल्याला efficient parallel operation पाहिजे of two or more than two single phase transformer, then the potential difference at a full load condition, चं जे काही potential difference आहे, we are writing here VL, that is load voltage, or it may be full load voltage. Okay, so this voltage at a full load condition across the transformer internal impedance should be equal. Okay, हे voltage आणि ट्रान्सफॉर्मरचा जो काही percentage per unit value of impedance असेल, so this impedance it should be equal. So this is the necessary condition आहे already. Now this condition ensures that the load sharing between two single phase transformer is according to the rating of each transformer. आता load share किती करतोय, it should be depends upon its individual rating. त्याच्या रेटिंग वरती काय राहील, डिपेंड्स राहील. ओके, so it should be depends upon its individual rating of the transformer, and the per unit equivalent impedance are not equal, then the transformer will not share the load in proportion of their kVA rating. मी काय सांगितलं, कंडिशन percentage impedance or the per unit impedance of the transformer remains same. per unit impedance कसा पाहिजे, सेम पाहिजे. If the per unit impedance are not equal of both the transformer, then the transformer will not share the load in the proportion of their kVA rating. त्याच्यानंतर जे ट्रान्सफॉर्मर आहेत, so it will not share the load in the proportion of kVA rating. kVA rating च्या proportion मध्ये ते शेअर करणार नाहीत. And as a result, the overall rating of the transformer bank will be reduced. त्याच्यामुळे काय होईल, जे ओव्हरऑल रेटिंग बँकचा आहे, दॅट मीन्स 2 ट्रान्सफॉर्मर कनेक्ट केले, इट इज नथिंग बट 2 ट्रान्सफॉर्मर बँक इज देअर. 3 ट्रान्सफॉर्मर कनेक्ट केले, इट इज नथिंग बट 3 ट्रान्सफॉर्मर बँक इज देअर. ओके, so overall rating of this transformer bank it will be reduces. ट्रान्सफॉर्मरची एक बँक फॉर्म होईल, 2 किंवा 2 पेक्षा अधिक ट्रान्सफॉर्मर ज्यावेळेस आपण पॅरल मध्ये पुट करतोय त्यावेळेस. सो ओव्हरऑल रेटिंग इट विल बी रिड्युस्ड, दॅट इज लोड रेटिंग इट विल बी reduces. Now this equation can be write in this form also, that is IAZA is equals to IBZB. So हे शिफ्ट केलं, ZB इकडे शिफ्ट केला, IA इकडे शिफ्ट केला, so it is nothing but IAZA is equals to IBZB. Okay, so if this equation it can be write in this form also. Now the current in this equation 7 and 8, 7 आणि 8 इक्वेशन मध्ये जो करंट आहे, that is IA is equals to IA, it is equals to load current IL into opposite transformer impedance divided by sum of both the transformer impedance. दोन्ही ट्रान्सफॉर्मरचे इम्पिडन्सची सम. Similarly, IB is equals to, that is current share by transformer B is equals to load current IL into opposite transformer impedance, that is ZA divided by ZA plus ZB. Okay, ZA plus ZB. Now the current equation it will be shown here, that is IA and IB is changed, this current it will be changed into a voltage ampere by multiplying the two equation by the common load voltage. याला जर आपण कॉमन लोड व्होल्टेज न मल्टिप्लाय केलं, दॅट इज VL न. So if we are multiplying this current equation by VL, so therefore we got the power shared by each and every transformer. प्रत्येक ट्रान्सफॉर्मर न शेअर केलेली पॉवर आपण काय करू शकतो, कॅल्क्युलेट करू शकतो. सी if we multiply by that is SL. Do you know that the power equation, that is P, or it may be here we are representing S. S is nothing but power. It is equation V into I. V into I जे इक्वेशन आहे ते पॉवरचं आहे. ओके, सी SL it is nothing but load power. It is equals to load voltage VL into load current IL. Okay, see the total load in the volt ampere is equals to SL is equals to VL into IL. And if we want to calculate the volt ampere or the power shared by transformer A, that is SA is equals to terminal voltage VL and into the current shared by transformer, that is IA. Okay, VL into IA. And similarly for volt ampere, that is power shared by transformer B, it is equals to load voltage VL into current shared by that transformer is nothing but IB. Okay, see SB is equals to VL into IB. Now hence the various equation will be written as shown in this below. आपण याच्यामध्ये बघा काय व्हॅल्यू पुट केली. सो VL into IL is nothing but SL आहे. Okay, so if we put this value, बघा कोणती व्हॅल्यू पुट केल्यानंतर इक्वेशन गॉट होते SA is equals to VL into IA. इथं जर मी IA ची व्हॅल्यू पुट केली, what this equation it will be, VL is equals to, sorry, SA is equals to VL IL into ZB divided by ZA plus ZB. Okay, so this VL into IL, what is VL into IL? What is VL into IL? Product of load voltage and load current. It is nothing but काय, product of VL into IA. Load side KVA, no? Here it is equation is there. SL is equals to VL into IL. So instead of writing VL into IL, I am putting here SL. So see, the equation becomes SA is equals to ZB divided by ZA plus ZB into SL. Similarly, SB is equals to ZA divided by ZA plus ZB into SL. Okay, So this one is the equation, that is 11 and 12 number equation is nothing but load share or kVA rating of each and every transformer. Load kVA of each transformer, that is load kVA of transformer A, load kVA of load kVA of transformer B, transformer B चा load kVA. Now if we equate these two equation, या दोन्ही इक्वेशन जर आपण इक्वेट केले, सॉरी इक्वेटिंग दिस टू इक्वेशन, देन जर हे दोन्ही इक्वेशन इक्वेट केले फॉर सेम केव्हीए रेटिंग, सेम केव्हीए रेटिंग साठी जर हे दोन्ही इक्वेशन इक्वेट केले, सो युअर इक्वेशन बिकम्स SA, or we are dividing equation 11 by equation 12. Equation 11 ला equation 12 ने काय केलं, डिवाइड केलं. So what will happen, SA divided by SB, SA divided by SB, it is equals to ZB divided by ZA plus ZB, ZB divided by ZA plus ZB into SL divided by, याच्या डिवाइड मध्ये काय येईल, ZA divided by ZA plus ZB, ZA divided by ZA plus ZB into SL. High SL get cancel, high SL and this SL get cancel. Denominator term it will be cancel, denominator ची term पण काय होईल, cancel होईल. So equation becomes SA divided by SB is equals to ZB divided by ZA. So rating is also depends upon the impedance. So see, according to this impedance equation, that is equation 13, it will be tells that the volt ampere load on each single phase transformer, again it is inversely proportional to its impedance. Okay, so जसा current inverse proportion मध्ये आहे, so similarly the kVA rating or volt ampere load of each and every transformer, it will be depends upon their kVA rating and it will be inversely proportional to that of load impedance. त्याच्या respective load impedance ला काय असेल, inversely proportional असेल. Okay, now hence to share the load in the proportion मध्ये जर लोड शेअर करायचं असेल, अकॉर्डिंग टू देअर रेटिंग, the transformer should have the impedance which is inversely proportional to their rating. ट्रान्सफॉर्मरचा इम्पिडन्स असा पाहिजे की त्याच्या रेटिंगला इनवर्स प्रोपोर्शन मध्ये पाहिजे. सो दिस इज वन ऑफ द MCQ क्वेश्चन. सो हेन्स टू शेअर द लोड इन द proportion to their rating, the transformer should have the impedance, ट्रान्सफॉर्मरचा इम्पिडन्स इट इज इनवर्सली प्रोपोर्शनल टू देअर रेटिंग. त्याच्या रेटिंगला काय पाहिजे, VA रेटिंगला इनवर्स प्रोपोर्शन मध्ये पाहिजे. ओके, देन द लोड शेअर इट विल बी हॅपन इन द प्रोपोर्शन ऑफ देअर रेटिंग. त्याच्या रेटिंग मध्ये काय होईल, लोड शेअर होईल. ओके, सो आय थिंक ऑल ऑफ यू गेटिंग दिस वन. हे लक्षात आलं असेल सगळ्यांच्या. याच्यामध्ये कोणाला काय डाऊट आहे का? We have already derived equation up to IA and IB. Today we have calculated the SA and SB, that is load share or the VA load shared by transformer A, and VB, that is volt ampere, load share by transformer B, transformer B न share केलेला load. Okay, getting all of you? लक्षात आलंय का?
Yes, sir.
Okay, now we will start the next one point, is that auto transformer. Okay, so auto transformer, we will start that point, that is auto transformer. Auto transformer, it is nothing but it is one type of electrical transformer. First of all, we will discuss regarding what is auto transformer. So auto transformer, it is nothing but it is an electrical transformer. It is having an only one winding. Okay, so only one winding. And in case of ordinary winding, there are how many winding? In case of ordinary transformer, there are how many winding? किती असतात? हॅलो, आपला जो काय आपण आता सिंगल फेज ट्रान्सफॉर्मर बघितला त्याच्यामध्ये किती वाइंडिंग होते? सांगा. Two winding, that is primary winding and secondary winding. And there are, whether there is a electrical connection in between that two winding, त्या दोन वाइंडिंगच्या मध्ये इलेक्ट्रिकल कनेक्शन होतं का?
No.
No. Whether there is a magnetic connection is there? In case of ordinary transformer, magnetically connected होते का ते? हाँ, इलेक्ट्रिकल कनेक्टेड होते का? नाहीये. मॅग्नेटिकली,
इंडक्टिव्हली होते.
इंडक्टिव्हली होते. What is the transformer principle?
Magnetically होते.
Magnetically connected, no? That means these two transformer are not electrically connected, but it is magnetically coupled. असा मी एक वर्ड वापरला होता ना? These two winding or the two coil are not electrically connected but magnetically coupled. So see, magnetically coupling होतं, त्याच्यासाठी कोर यूज करतोय आपण. प्रायमरी वाइंडिंग आहे, देयर इज अ मॅग्नेटिकली कपलिंग बिटवीन दिस टू वाइंडिंग. याचा फ्लक्स याच्याशी लिंक होतो, दॅट मीन्स मॅग्नेटिक कपलिंग आहे. याच्यामध्ये इलेक्ट्रिकल कनेक्शन आहे का कुठं? दोन वाइंडिंग मध्ये, प्रायमरी आणि सेकंडरी मध्ये नाहीये ना? हा. सो सी, this is MCQ question and this difference is in the auto transformer. Auto transformer, it is an electrical transformer. It is having an only one winding. See, ordinary transformer मध्ये दोन winding आहेत, primary आणि secondary. These are not electrically connected but it is magnetically coupled to each other. Okay, so in case of auto transformer, it is only one winding it can be present. Okay, so in that one winding, some part of that winding it is act as a primary winding and some part of the winding it will be act as a secondary winding. So that means there are electrical connection it will be present in between these two winding, that is primary winding and secondary winding. Also there is a magnetically connection it will be present in between inductively connected electrical connection आहे, so that it is inductively connected. So EMF induced in the secondary coil, it is inductively. Okay, so EMF जो काय secondary coil मध्ये induce होईल, so this EMF it will be induces inductively. See, it is having an only one winding, याच्यामध्ये एकच winding आहे. Some part it will be act as a primary winding and some of the part of that winding it will be act as a secondary winding. See, this one is the only one winding transformer. हा जो काय आहे एक winding चा transformer आहे. So from terminal A to terminal B, this will be act as a primary side and this total number of turns it will be act as a primary winding, right? And from point C to point B, this number of turns it will be act as a secondary winding. याच्यामधल्या या total number of turns जे असतील primary winding म्हणून act होत आहेत, and from C to B, point C to B, it will act as a secondary winding. Okay, it will act as a secondary winding. Okay, लक्ष देते. So see, on the primary side there is a supply voltage is given. On the secondary side there is a load, it can be putted or it may be load, it can be connected. See, what will happen? The auto transformer. So auto transformer, it is nothing but it will be prefix referred to the single coil acting alone. Okay, याच्यामध्ये जो काय ॲटो हा शब्द यूज केलेला आहे, दॅट इज ॲटो प्रिफिक्स. ट्रान्सफॉर्मरला जो काय प्रिफिक्स लावलेला आहे ॲटो. So auto, the meaning of that, it is nothing but it is a single acting alone. That means in the Greek language, it will called as a self or single. Okay. So auto is prefix. It can be given to that of transformer, that it is having an single coil, or this transformer it is acting on single coil. Okay. So not to any automatic mechanism, there is no any automatic mechanism. And auto transformer, it is similar to that of two winding transformer. जो काय आपला ऑर्डिनरी ट्रान्सफॉर्मर आहे किंवा जो काही टू वाइंडिंग ट्रान्सफॉर्मर असेल, so auto transformer it will be similar to that of two winding transformer. Okay. So but the difference between that means it will vary in the way primary and secondary winding of the transformer are interrelated. Okay. See, primary आणि secondary winding चं रिलेशन कसं आहे त्याच्यावरती फक्त डिफरन्स आहे. So in case of ordinary transformer, the primary and secondary winding are not electrically connected, but it is magnetically coupled to each other. So the EMF induced in the secondary coil is due to the magnetism, or it may be magnetism. That is, we can call it as a magnetically induced EMF. It will be induces in the secondary. In case of auto transformer, there is a electrical connection between these two winding. त्या दोन वाइंडिंग मध्ये इलेक्ट्रिकल कनेक्शन आहे. So the EMF induced in the secondary winding of the auto transformer, it is due to inductively EMF induce होतो in case of auto transformer, आणि magnetically EMF induce होतो in case of two winding transformer. Just this is the difference between two winding transformer and auto transformer. Okay. So that means there is a how the correlate or interrelationship between two winding त्याच्यावरती काय राहील, डिपेंड राहील. Now in an auto transformer, one single winding used as a primary winding as well as secondary winding. याच्यामधली जी काय एक सिंगल वाइंडिंग आहे तीच प्रायमरी वाइंडिंग म्हणून पण आपण यूज करतो, and some part of that it can be used as a secondary winding. But in case of two winding transformer, in case of two winding transformer, the two different winding are used. त्याच्यामध्ये टू वाइंडिंग ट्रान्सफॉर्मर मध्ये आपण टू डिफरंट वाइंडिंग काय करतोय, यूज करतोय. ओके. नाउ द सर्किट डायग्राम फॉर द ऑटो ट्रान्सफॉर्मर इट विल बी शोन हियर. इथे दाखवली बघा सर्किट डायग्राम. ओनली वन वाइंडिंग इट कॅन बी act as a primary, also some part of that winding it will be act as a secondary. According to this, whether it is step up transformer or step down transformer, हा जो दाखवलेला आहे डायग्राम मध्ये, वेदर इट इज स्टेप अप और स्टेप डाउन, hello, okay, no one telling, we will discuss. See, the winding AB it will having an total number of turns. Suppose या A to B पर्यंत जे काय वाइंडिंग आहे, that means primary side, it is having an total number of turns is equals to N1, and the secondary winding from C to B, that is C to B, it is having an number of turns is nothing but N2. याच्या N2 number of turns आहेत. That means this is a only one single coil. There is a tapping, it can be between the point C. पॉइंट सी ला काय केलेलं आहे, टॅपिंग केलेलं आहे. म्हणजे टॅपिंग, व्हॉट इज मीन बाय टॅपिंग? टॅपिंग मीन्स व्हॉट? टॅपिंग माहिती आहे का तुम्हाला? माहित असेल तर यस, माहित नसेल तर नो. जस्ट टेल समथिंग. What is meant by tapping? Okay, see, the tapping is nothing but connecting at a particular point. आपण जो generally I will tell in Marathi. आपण जो आकडा टाकायचा म्हणतो किंवा आकडा टाकतो, सो इट इज नथिंग बट वी आर टॅपिंग ऑन दॅट पर्टिक्युलर पॉइंट. त्या पॉइंट वरती काय करतो, टॅपिंग करतो, म्हणजेच आपण आकडा टाकतोय. ओके, सो टॅपिंग it is nothing but on that winding and on that total number of winding there is a one tapping it can be done on the point C. Okay, point C ला काय केलंय, टॅपिंग केलंय, and from that this number of turns, that is from C to B number of turns, it will be act as a secondary side. या secondary side म्हणून काय होतील, act होतील. So whether it is step up or step down, याच्या n1 number of turns greater आहेत का n2 number of turns greater आहेत? n1 number of turns जास्त आहेत का n2 number of turns जास्त आहेत?
N2 greater आहे.
n2 greater आहेत number of turns. टर्न्स माहिती आहेत ना, टर्न्स?
No, sir. N1 is greater than N2.
n1 is greater than n2. So n1 is greater than n2. n1 is greater than n2. It is nothing but या प्रायमरी वाइंडिंगच्या टर्न जास्त आहेत ऍज कम्पेअर्ड टू दॅट ऑफ सेकंडरी वाइंडिंग. कारण सेकंडरी वाइंडिंग इथं टॅपिंग केलेलं, इथून एवढ्याच टर्न ह्या सेकंडरी वाइंडिंग साठी असतील, आणि n1 दॅट मीन्स प्रायमरी वाइंडिंग साठी या टोटल नंबर ऑफ टर्न्स असतील. वेदर इट इज स्टेप अप और स्टेप डाउन, equation of kVA rating or the transformation ratio n1 divided by n2, it is equals to v1 divided by v2, it is equals to e1 divided by e2, it is equals to i2 divided by i1. Okay, it is equals to k असतं, right? See, n1 is greater than n2, that means v1 is greater than v2, right?
Yes, sir.
ओके, n1 ग्रेटर आहे, नंबर ऑफ टर्न्स इन्क्रीज झाल्या, ऑटोमॅटिकली नंबर ऑफ दॅट मीन्स फ्लक्स लाईन्स ऑफ फोर्स इन्क्रीज होतील. इफ द इंड्यूस्ड EMF or the flux, it will be increases. According to the induced voltage, it will be also increases. Okay, so n1 increases, that means v1 increases, or the n1 या greater असतील as compared to n2 is nothing but v1 is greater than v2. v1 is greater than v2. So primary voltage, it is greater than that of secondary voltage, then it is step up or step down. Voltage step up होते का step down होते?
Step down.
Step down होते ना. So see, suppose this voltage is nothing but 11,000 volt. हे 11,000 volt आहे, that means 11 kV ची लाईन आहे. And suppose we are doing using here transformer and it is converted into 440 volt. हे 440 volt ला काय केले, कन्वर्ट केले. That means हाय व्होल्टेजचं कन्वर्जन लो व्होल्टेज मध्ये, वी आर स्टेप डाउनिंग द व्होल्टेज. स्टेप डाउनिंग द व्होल्टेज म्हणजे 11,000 वोल्टचं कन्वर्जन मी 440 वोल्ट मध्ये करतोय. सो आय एम स्टेपिंग डाउन द व्होल्टेज, सो इट इज द स्टेप डाउन ट्रान्सफॉर्मर. अँड इन केस ऑफ स्टेप अप ट्रान्सफॉर्मर कसा असेल? So if I draw the diagram for that is step up transformer. Similarly, this one is the winding. See, I will draw here. Suppose this terminal is here, A to B and C to B. So suppose this one is the primary, ही primary आहे, या number of turns primary च्या आहे, and this one is the number of turns of the secondary side. Suppose this is n1 and this one is the n2. ह्या काय झाल्या, n2 झाल्या. Whether n1 is greater than n2 or n2 is greater than n1?
N2 is greater than N1.
n2 is greater than n1. So n2 is greater than n1 according to transformation ratio. v2 is greater than v1. v2 हा v1 पेक्षा काय आहे, जास्त आहे. Whether v2 is greater than v1, that means whether it is step up or step down?
Step up.
Step up. ते व्होल्टेज काय करते, स्टेप अप करते. ओके, सो अकॉर्डिंग टू there are two types of transformer, that is step up transformer and step down transformer. Okay, step up transformer and step down transformer, and it is depends upon number of turns. Okay, it is depends upon number of turns. See, the winding, that is transformer winding, only one winding of the transformer, it will be act as a primary winding, also it will be act as a secondary winding. Secondary winding म्हणून पण act होतील, primary winding म्हणून पण काय होतील, act होतील. Okay, now if the V1 is the supply voltage or the voltage applied to that of terminal, so voltage applied to the terminal A to C, then the voltage per turns in this winding, या वाइंडिंग मध्ये किती पर टर्न ला व्होल्टेज किती असेल, दॅट इज V1 टोटल व्होल्टेज अप्लाइड टू दॅट ऑफ वाइंडिंग डिवाइडेड बाय नंबर ऑफ टर्न्स. एका टर्न्सचं किती व्होल्टेज असेल हे कशावरती डिपेंड्स असेल, V1 डिवाइड बाय N1. V1 डिवाइड बाय N1 वरती डिपेंड्स असेल. सप्लाय व्होल्टेज V1 आहे, सपोज सप्लाय व्होल्टेज 230 आहे, राइट. Then it is having a number of turns, N1 is equals to 100 आहे. N1 is nothing but it is equals to 100 number of turns. तर एका टर्नचं व्होल्टेज किती असेल, इट इज नथिंग बट 230 डिवाइड बाय 100. 230 divided by 100, it is nothing but 2 divided by 3, sorry 2.3. So 2.3 volt per number of turns. So voltage per turn in the winding is equals to V1 divided by N1. V1 divided by काय असेल, N1 असेल. Okay, so this equation we want to derive. Before discussing about equation, this is the transformer, that is auto transformer, and whether the winding requirement is less or more as compared to that of ordinary transformer. ऑर्डिनरी ट्रान्सफॉर्मरला कंपेअर करता याच्यामध्ये जी काय वाइंडिंग लागते कॉपरची ही कमी लागेल का जास्त लागेल, वेदर इट इज लेस और ग्रेटर. सी same kVA rating चा transformer, if I construct one of the same kVA rating transformer, that is हा एक transformer मी construct करतोय, that is 2 winding transformer. Suppose this is a 2 winding transformer. Okay, having an kVA rating, it is nothing but 1 kVA चा आहे. So similarly I want to construct auto transformer of 1 kVA. 1 kVA चा ऑटो ट्रान्सफॉर्मर काय करतोय मी, कन्स्ट्रक्ट करतोय. ओके, सो while constructing auto transformer having an same kVA rating, whether this winding copper it is required as equal or it may be as less or it may be as more in case of auto transformer. Can anyone tell? इथं जे काही वाइंडिंग आहे सेम नंबर ऑफ टर्न्स असतील किंवा सेम केव्हीए रेटिंग आहे दोन्हीचं, पण इथं लागणाऱ्या नंबर ऑफ टर्न्स किंवा इथं लागणारी कॉपर वायर तेवढीच कॉपर वायर ऑटो ट्रान्सफॉर्मरला लागेल की वेदर इट इज लेस और इट मे बी वेदर इट इज मोर, लेस. Okay, see, right answer, that is less copper it will be required. So that means there is a copper saving it will be occur. त्याच्यामध्ये कॉपर सेव्हिंग ऑकर होईल. बघा, सेम केव्हीए रेटिंगचा ट्रान्सफॉर्मर आय वॉन्ट टू कन्स्ट्रक्ट, मला सेम केव्हीए रेटिंगचा ट्रान्सफॉर्मर कन्स्ट्रक्ट करायचा आहे. याच्यासाठी सेपरेट प्रायमरी वाइंडिंग लागेल, सेपरेट सेकंडरी वाइंडिंग लागेल. बट इन केस ऑफ ऑटो ट्रान्सफॉर्मर ओनली वन वाइंडिंग इट विल बी ऍक्ट ॲज अ प्रायमरी ऑल्सो सेकंडरी ऑल्सो. एकच वाइंडिंग याच्यामधला हा टोटल पार्ट इट विल बी ऍक्ट ॲज अ प्रायमरी and some of the tapping it can be happen and this part it will be act as a secondary. So there is a copper saving it will be occur in case of auto transformer. Auto transformer मध्ये काय होईल, copper saving होते. That means copper requirement it is less as compared to that of ordinary transformer. Copper requirement it is less in case of auto transformer as compared to that of ऑर्डिनरी ट्रान्सफॉर्मर. ऑर्डिनरी ट्रान्सफॉर्मर पेक्षा जे काही कॉपर रिक्वायरमेंट आहे ते काय असेल, लेस असेल. ओके, इट विल रिक्वायर लेस. सो देयर इज वन डेरिवेशन इन केस ऑफ ऑटो ट्रान्सफॉर्मर इज दॅट ॲट हाऊ मच अमाऊंट ऑफ कॉपर इट विल बी सेव्ह, किती अमाऊंटचं कॉपर काय होतं याच्यामध्ये सेव्ह होते. ओके, So while constructing this transformer, how much amount of copper it will be saved in case of auto transformer? So we are deriving that equation, that is saving of copper in case of auto transformer. ऑटो ट्रान्सफॉर्मर मध्ये किती कॉपर सेव्ह होते त्याचं एक डेरिवेशन आहे छोटस. सो वी विल डिराइव दॅट डेरिवेशन. बिफोर डिराइविंग दॅट डेरिवेशन वी विल डिस्कस दॅट वन. दॅट मीन्स कॉपर रिक्वायरमेंट इज सेम. अगेन ऑटो ट्रान्सफॉर्मर इट इज सिमिलर टू दॅट ऑफ टू वाइंडिंग ट्रान्सफॉर्मर. हा सेम टू वाइंडिंग ट्रान्सफॉर्मर सारखा आहे, बट वन ऑफ द व्हेरिएबल टर्मिनल इज दियर. त्याच्यामध्ये एक आउटपुट साइडचं व्हेरिएबल टर्मिनल असेल. ओके, दॅट मीन्स वी आर एबल टू व्हॅरी द आउटपुट व्होल्टेज. त्याचं जे काय आउटपुट व्होल्टेज असेल ते आपण काय करू शकतो, व्हॅरी करू शकतो. कॅन एनीवन सी द ऑटो ट्रान्सफॉर्मर? बघितलेलं आहे का तुम्ही ऑटो ट्रान्सफॉर्मर? बघितलेलं आहे का?
नो सर.
You have not seen. Okay, so auto transformer, it is nothing but there is a only one winding, एकच winding असेल, and suppose the supply voltage is nothing but 230. याचा जर supply voltage 230 असेल, this is nothing but this one is the variable terminal. हे variable terminal आहे. So if we are vary this terminal, हे जर टर्मिनल आपण व्हॅरी केलं दॅट मीन्स याचं टॅपिंग व्हॅरी होत आहे. जर हे फुल याला कनेक्ट केलं इट विल गिव्ह द 230 वोल्ट सप्लाय ऍट द आउटपुट साइड. सेकंडरी साइडला काय करेल ते 230 वोल्ट देईल, बिकॉज टोटल नंबर ऑफ टर्न्स इट विल बी ऍक्ट ॲज अ सेकंडरी. इफ वी रिड्यूस द नंबर ऑफ टर्न्स ऑटोमॅटिकली व्होल्टेज इट विल बी रिड्यूसेस. व्होल्टेज पण काय विल रिड्यूस होईल. इफ वी रिड्यूस द दिस टॅपिंग और इट मे बी इफ वी व्हॅरी दिस टर्मिनल, then the automatically if the turns reduces or the turns increases, जर टर्न्स रिड्यूस झाल्या तर व्होल्टेज रिड्यूस होईल, टर्न्स इन्क्रीज झाल्या की व्होल्टेज काय होईल, इन्क्रीज होईल. सो सिमिलरली दिस ट्रान्सफॉर्मर इट विल बी like this, that is there is one variable pot or it may be variable terminal. By varying this terminal we are able to change the output side voltage. आउटपुट साइडचे जे काही व्होल्टेज असेल ते आपण चेंज करू शकतो. I think in the previous one practical, आपलं एक प्रॅक्टिकल झालं ना? नाही, हा याचं प्रॅक्टिकल घेतलं ना आपण OCSC टेस्टचं. हॅलो, we have covered one practical
Yes, sir.
OCSC test on VLab. त्याच्यामध्ये आपण पहिल्यांदा ऑटो ट्रान्सफॉर्मर कनेक्ट करत होतो. सो त्याच्यामध्ये एक व्हेरिएबल टर्मिनल होतं और पॉइंटर होता. तो पॉइंटर व्हॅरी करून आपण काय करत होतो, सप्लाय व्होल्टेज अप्लाय करत होतो. राईट नो?
येस सर.
बरोबर ना?
येस सर.
That means we are able to vary the output voltage by using an auto transformer. ऑटो ट्रान्सफॉर्मरचा यूज करून आपण आउटपुट व्होल्टेज काय करत होतो, व्हॅरी करत होतो. सो वी आर एबल टू गिव्ह द voltage to that of secondary, or we are able to vary the secondary voltage, and this voltage it can be provided to that of desired load. desired load ला ते voltage काय केलं जातं, प्रोव्हाइड केलं जातं. ओके, see so the voltage per turns in the winding is V1 divided by N1. प्रत्येक टर्न्स मधलं जे काही व्होल्टेज असेल V1 divided by N1. hence the voltage across portion B to C it is equals to B to C च्या पोर्शन मधलं जे काय व्होल्टेज असेल, सो नंबर ऑफ पर टर्न व्होल्टेज इंटू नंबर ऑफ टर्न्स. बघा, सपोज आपण मगाशी कॅल्क्युलेट केलं एका नंबर ऑफ टर्नचं व्होल्टेज किती आहे, 2.3 आहे. राईट, जर टोटल नंबर ऑफ टर्न्स 100 असतील देन द व्होल्टेज बिकम्स 100 इंटू 2.3. किती येते, 100 इंटू 2.3 इट इज नथिंग बट 230. नो?
येस सर.
हा, सो इट इज 230. म्हणजे प्रायमरी साइडच्या टोटल नंबर ऑफ टर्न जर कन्सिडर केल्या तर त्याचं व्होल्टेज काय होईल, 230 होईल. इफ द सेकंडरी वाइंडिंग हॅव्हिंग अ नंबर ऑफ टर्न्स इज इक्वल टू 50. याच्या नंबर ऑफ टर्न्स काय आहेत, 50 आहेत. सो व्हॉट इज द इक्वेशन, दॅट इज व्होल्टेज पर टर्न इन दिस वाइंडिंगचे व्होल्टेज पर टर्न V1 डिवाइड बाय N1 आहे. V1 डिवाइड बाय N1 आपण कॅल्क्युलेट केला 2/3. 2/3 काय आहे, व्होल्टेज पर टर्न आहे, एका टर्नचं व्होल्टेज. जर तिथं 50 नंबर ऑफ टर्न्स असतील तर व्हॉट इज द व्होल्टेज, दॅट इज 2.3 इंटू 50 किती लिहे 115. That means the tapping it can be done exactly at the 50% of tons, 50% of total number of tons. Total number of टनच्या 50% ला काय केलंय टॅपिंग केलंय. जर टॅपिंग चेंज केलं दॅट मीन्स सपोज द नंबर ऑफ टन्स इज नथिंग बट 40. नंबर ऑफ टन्स या 40 आहे. सो 40 into 2.3 we are considering this example. I am taking just example 40 into 2 जी काय व्हॅल्यू येईल that means this 50% is nothing but 100 number of टनच्या 50% टन्स आपण पहिल्यांदा कन्सिडर केल्या. परत 40 नंबर is nothing but less than 50%. Less than 50% number of tons it will be present in case of secondary winding. Hence the voltage across portion B to C will be equation V1 divided by N1 into N2. And from the figure this voltage हे जे काय voltage असेल is nothing but output voltage V2. हे जे काय voltage असेल this voltage is nothing but V2. So if we equate these two equation ज्यावेळेस आपण हे दोन इक्वेशन इक्वेट करतोय that is V1 divided by N1 V1 divided by N1 into N2 it is equals to V2. V1 divided by N1 V1 divided by N1 into N2 it is equals to V2. If we rearrange this equation, so just shift this V1 into right hand side, so it becomes V2 divided by V1 it is equals to N2 divided by N1 N2 divided by N1 it is equals to transformation ratio K. It is equals to transformation ratio K. See this transformation ratio K is this formula. It is this formula it will be same in case of auto transformer also or in case of two winding transformer also. Two winding transformer मध्ये किंवा auto transformer मध्ये this formula that is transformation ratio K it will be same or it will be similar. तो काय असेल similar असेल. Okay, that is the transformation ratio we have derived by using this auto transformer. Auto transformer चा यूज करून आपण त्याचा ट्रान्सफॉर्मेशन रेशो काय केलंय डिराइव केलं. Now we will discuss regarding advantages, that is advantages of auto transformer. Advantages of a auto transformer चे advantages. So see first one advantages is that the advantages of auto transformer it will include for transformation ratio it is equals to 2. The size of the auto transformer would be approximately 50% of the corresponding size of two winding transformer. Okay, see पहिला advantages आहे auto transformer च size, that is size of auto transformer is less than that of size of two winding transformer. ऑटो ट्रान्सफॉर्मर ची साइज जी आहे ती टू वाइंडिंग ट्रान्सफॉर्मरच्या साइज पेक्षा काय येईल लेस येईल. बिकॉज इन केस ऑफ टू वाइंडिंग ट्रान्सफॉर्मर देयर आर सेपरेट टू वाइंडिंग इज देयर. अगेन द नंबर ऑफ टर्न्स इट विल बी मोर. Also the copper requirement, that means copper requirement for construction of winding it will be more in case of two winding transformer. So see if the transformation ratio is equals to 2 म्हणजे ऑर्डिनरी ट्रान्सफॉर्मरच्या डबल जर ट्रान्सफॉर्मेशन रेशो केला ऑटो ट्रान्सफॉर्मरचा then also size of that auto transformer it is 50% of the corresponding size of two winding transformer. त्यावेळेस size of auto transformer it is 50% of that of corresponding two winding transformer. Two winding transformer च्या 50% size येईल. Okay, see suppose the two winding transformer having size of 2/3 it is nothing but 6 square meter or it may be square feet. Okay, see 2/3 चा जर auto transformer big size चा असेल same kVA rating चा, if we want to construct the auto transformer having double this size, suppose हा 1 kVA rating चा ट्रान्सफॉर्मर 2/3 साइजचा आहे. याच्या डबल असेल दॅट इज 2 kVA ट्रान्सफॉर्मर, याची साईज परत इन्क्रीज होणार इन केस ऑफ 2 वाइंडिंग ट्रान्सफॉर्मर. But in case of auto transformer, if we want to construct the double kVA rating transformer as compared to that of ordinary transformer, the size should be 50% of that of this transformer. या ट्रान्सफॉर्मरच्या 50% काय असेल, साइज असेल. Okay, so this is first one advantages is that for the transformation ratio is equals to 2. The size of auto transformer, it will be approximately 50% of the corresponding size of 2 winding transformer. Now for transformation ratio say 20, however the size would be 95%. Okay, size it will be 95%. Now the saving in the cost, baga, if the size reduces there is a cost saving is there. जर साइज कमी झाली तर कॉस्ट कमी होईल का? कॉस्ट कमी होईल का?
Yes, sir.
ओके, द सेव्हिंग इन द कॉस्ट ऑफ द मटेरियल, अगेन साइज रिड्यूस झाली त्याच्यासाठी लागणारं कोर कन्स्ट्रक्शन, देन कॉपर कन्स्ट्रक्शन इट विल बी ऑल्सो रिड्यूसेस. इफ द कोर कन्स्ट्रक्शन कॉपर कन्स्ट्रक्शन रिड्यूसेस दॅट मीन्स मटेरियल रिक्वायरमेंट इज रिड्यूसेस, मटेरियलची रिक्वायरमेंट रिड्यूस होईल. So the saving in the cost, if the material requirement is reduces, that means there is a cost saving. Saving in the cost of the material is of course not in the same proportion. So the saving of the cost is appreciable when the ratio of the transformer is low, that is lower than 2. Transformer चा ratio ज्यावेळेस lower than 2 असेल, then the saving of cost it will be happen. Okay, thus first one advantages it will be conclude that thus auto transformer is smaller in size and cheaper. Auto transformer हा small size मध्ये आहे as compared to that of ordinary transformer, and it is having an cheaper as compared to that of ordinary transformer. Ordinary transformer ला compare करता त्याची size less असेल, that means small in size. Also as compared to that of ordinary transformer, it is a cheaper, that means cost it is less. So this is the first one advantages. Second one advantages of the auto transformer is that an auto transformer has higher efficiency than a 2 winding transformer. As compared to that of 2 winding transformer, the efficiency of the auto transformer it is high. Efficiency काय असेल, high असेल. Because why efficiency is high? Because less ohmic loss, winding च्या turns कमी आहेत, so that resistance of winding is also less. If the resistance of winding is also less, so that ohmic loss, that is IR loss जो आहे तो less असेल. Okay, that means ohmic loss. Also the core requirement is less. Core जो required आहे, that means core construction it is less. Due to that the core loss it is also reduces. Due to the transformer material it will be reduced. त्यावेळेस transformer material reduce होईल, त्यावेळेस core loss पण reduce होईल. Size reduces, that means core losses reduces. Okay, so these are the advantages. So that's why the efficiency of the auto transformer it is high as compared to that of ordinary transformer or the 2 winding transformer. 2 winding transformer ला compare करता याची efficiency जी असेल ती high असेल. Okay, the efficiency of that it is high. Now next one advantages is that auto transformer has better voltage regulation. Auto transformer has the better voltage regulation as voltage drop in the resistance and the reactance of single winding is less. याचा रेजिस्टन्स मी सांगितलेला, that is I into R, it is less. Also reactance drop is also less, that is I into X, it is also less. So if the voltage drop and the reactance drop it will be less, so its regulation is high as compared to that of 2 winding transformer. 2 winding transformer ला compare करता auto transformer having an better voltage regulation, it is having an better voltage regulation. Due to the ohmic drop it is less, as well as the reactance of the winding, it is also less. Winding चा reactance पण काय आहे? Less आहे. Okay, now so these are the some of the advantages. Also there are some of the disadvantages of that of auto transformer. Auto transformer चे काही disadvantages आहेत. We will discuss that disadvantages. Auto transformer, it is having a disadvantages is that, see, first one disadvantages is nothing but because of electrical conductivity in the primary and secondary winding, the lower voltage circuit is liable to be impressed upon the higher voltage. Okay, so see this one, first one advantages, disadvantages is that electrical conductivity आहे, that means there is electrical connection between primary and secondary. Primary winding आणि secondary winding मध्ये electrical connection आहे. So there is a electrical conductivity or the electrical connection between primary and secondary winding. So the lower voltage circuit is liable to be impressed upon the higher voltage circuit. Okay, so low voltage circuit, it can be impressed upon the high voltage. To avoid the breakdown, in the lower voltage circuit, it becomes necessary to design a low voltage circuit to withstand the high voltage. Okay, याच्यामुळे काय होतं, there is a breakdown, it will be happen जर low voltage circuit आणि high voltage circuit, that means HV and LV side आपण जी म्हणतो, that is high voltage and low voltage side, here it is same winding is there, so there will be sometimes breakdown, it will be happen. Okay, so to avoid that situation, there should be necessary is that while designing the low voltage circuit, it should be designed like that it is withstand the high voltage. लो व्होल्टेज सर्किट पण असं डिझाईन केलं पाहिजे की ते हाय व्होल्टेज पण डिझायर्ड करेल किंवा विथस्टँड करेल. ओके, सो दिस इज फर्स्ट वन डिसएडवांटेजेस. फर्स्ट वन disadvantages of the transformer, that is first one disadvantages of the auto transformer. Second one disadvantages is that the leakage flux between the primary and secondary winding is small, hence the impedance is low, and this result into severe short circuit current under fault condition. See, whether there is a leakage flux, it will be present in between primary and secondary in case of auto transformer. लीकेज फ्लक्स होत आहेत का? प्रायमरीचे प्रोड्यूस झालेले फ्लक्स सेकंडरीला इंड्यूस होतात, त्याच्यामधले काही फ्लक्स लीक होतात इन केस ऑफ ऑर्डिनरी ट्रान्सफॉर्मर. वेदर इट विल बी हॅपन इन केस ऑफ ऑटो ट्रान्सफॉर्मर? yes or no?
Yes, sir.
So leakage flux between the primary and secondary, primary आणि secondary मध्ये जे काही leakage flux आहेत ते small असतील as compared to that of two winding transformer. If the leakage flux is small, leakage flux जर small असेल तर leakage impedance it will be low, hence the impedance in the circuit it will be low, and this result, याचा result काय होतो? There is a result in the severe short circuit current under fault condition. When the fault occur in the transformer, that is auto transformer, there are several amount of short circuit current it will be flow. त्याच्यामधून short circuit current काय होईल? Flow होईल. So this is the second one disadvantages. हे जे आहे ते second one disadvantages आहे. Okay, now the third one is nothing but the connection on the primary and secondary side have necessarily needs to be same. Primary and secondary sides connection जे आहे, connection it should be necessarily same except when using interconnected starring connection. Except ज्यावेळेस आपण interconnected star connection करतोय, this one excepting all other connection it will be same. All other connection काय पाहिजे? Same पाहिजे. And if not like that, this introduces complication due to the changing primary and secondary phase angle. त्याच्यामुळे काय होतं? It will be while changing the primary and secondary phase angle, primary चा आणि secondary चा phase angle change करताना there is a complication it will be occur. Okay, So complication due to changing in the primary and secondary phase angle, primary and secondary phase angle, particularly in case of delta delta connection. आता हे delta delta connection, I think you people don't know delta connection. I think in the measurement you have studied the stars connection as well as delta connection. Delta connection, it will be like this, and the star connection is nothing but Y type connection, or it may be Y connection. Okay, so in case of delta delta connection, if the primary it is connected in delta, secondary it is also connected in delta. If the primary and secondary are also connected in delta delta, then while changing the primary and secondary phase angle, ज्यावेळेस आपल्याला phase angle change करायचा आहे, at that situation there is a complication, it will be occur. So this is third one disadvantage. Now fourth one disadvantage is that because of the common neutral in the star star connected auto transformer, that is star star connection चा जर auto transformer असेल, that is star star connected auto transformer, it is not possible to earth neutral of one side only. एका साइड ची न्यूट्रल जी आहे, only this neutral we want to ground, it is not possible. We want to ground both the neutral. Okay, so both their sides should have their neutrally either earth or isolated. दोन्ही साइडचं जे काही कनेक्शन असेल ते न्यूट्रल कनेक्शन पाहिजे. Both the sides have the neutral connection. Both the sides it is having a neutral connection, either are or it may be isolated. So this is one next one disadvantages. So this third one and fourth one disadvantages, it is related to three phase auto transformer. Three phase auto transformer related disadvantages आहेत. Next one, that is last one disadvantages, is that it is more difficult to maintain. It is more difficult to maintain. That means for maintaining purpose it is more difficult. Maintain करणं हे difficult आहे. So it is more difficult to maintain the electromagnetic balance of the winding when the voltage adjustment tappings are provided. म्हणजे voltage adjustment tapping जर provide केलेले असतील, then it is very difficult to manage the electromagnetic balance. त्याचा जो काही electromagnetic balance आहे तो manage करणं काय राहील, difficult राहील. Okay, it is very difficult to manage the electromagnetic balance when the tappings are provided. And it should be known that the provision of tapping on an auto transformer increases considerably the frame size of the transformer. Okay, जर टॅपिंगला आपण प्रोव्हिजन म्हणजे टॅपिंगचं प्रोव्हिजन दिलेलं असेल, then the considerable size of frame size of the auto transformer it will be that means increases. Okay, so it will increase the frame size of the auto transformer. Auto transformer ची जी काही फ्रेम आहे or the yoke असेल किंवा कोर असेल त्याची साइज काय होईल, increase होईल. And if the range of the tapping is very large, जर tapping ची range very large असेल, the advantages gained in the initial cost is lost to a great event. पहिल्यांदा आपण advantages म्हणतो इनिशियल कॉस्ट कमी आहे, ती जी कॉस्ट असेल increase होईल when the tappings are very large. ज्यावेळेस आपण maximum tapping provide करतोय, then the cost of that transformer it is also increases. त्या ट्रान्सफॉर्मर ची कॉस्ट पण काय होईल, increase होईल. Okay, so this is related to the disadvantages of auto transformer. हे auto transformer चे disadvantages आहेत. Now remaining point, that is derivation related to saving of copper in case of auto transformer. So we will discuss that derivation in the next lecture. Tell me, is there any doubt in case of auto transformer? Hello, याच्यामध्ये काय डाऊट आहे का ऑटो ट्रान्सफॉर्मर मध्ये? Give me reply. Is there any doubt? Hello, I am asking some question. No one is giving reply. Is there any doubt?
No, sir.
Okay. So in this way, we will conclude this today's lecture, and we will stop here.